Hello class, you're welcome to our mathematics class, and today we shall be looking at the topic sequence and series. So what does sequence mean? Sequence is a succession of terms generated according to some rule or law. So when we have sequence such as 1, 3, 5, 7, how does this sequence proceed? We have 1 here, and to get 3, that means 2 was added to 1 in order to get 3. Also, in order to get 5, 2 was added to the same 3 to get 5. And so we add 2 again to 5 to get 7. We keep adding 2 to the number in order to get the next one. Hence, we have a common difference here of 2. Okay, let's take a look at this next one. We have 83, 77, 71, 65, and so on. The first number here is 83, and then the next number is 77. It means that the numbers keep reducing by a particular common difference. For us to get 77, it means that 6 was removed from 83 in order to get 77. 6 was also removed from 77 in order to get 71. 6 was removed from 71 in order to get 65. And so we have a common difference of -6 in this other sequence. Under this sequence, we have what we call arithmetic sequence, also known as arithmetic progression. And arithmetic progression, AP, has a formula of nth term equal to first term plus n minus 1 into bracket D, where A represents the first term of the sequence. For instance, here this is the first term, 1. Here this is the first term, it's 3. And then n is the number of terms which we are dealing with, and D represents the common difference. And so this particular sequence is an example of an arithmetic sequence. Likewise, this. We have a similar sequence which is known as the geometric sequence. In geometric sequence, we could have something like, here the first term here is 2, and to get the next number, 2 is multiplied by 2. That is, we multiply this 2 by 2 to get 4. We multiply 4 by 2 again to get 8. We multiply 8 by 2 to get 16. We multiply 16 by 2 to get 32. And so we keep on multiplying by 2. Now we have so over here, what we have been using to multiply each of the term is known as the common ratio. And over here, the common ratio is 2. This leads us to what we know as the geometric progression or geometric sequence. And geometric sequence has a formula that the nth term, that is the term we are looking for, equal to the first term multiplied by the common ratio to the power of n minus 1, where A is the first term, R is known as the common ratio, n is the number of terms we are dealing with minus 1. Next, we have what we call a series. A series is the sum of a sequence. For instance, we could sum the arithmetic sequence. Like, we could be given 10 numbers and we could be told to add them together. So we have a formula which makes it easy for us to add. So hence we have what we call sum of arithmetic progression, which has a formula Sn equal to n over 2 into brackets 2a plus n minus 1 into bracket D. All these terms here are familiar. N is the number of terms we are dealing with, A is the first term, number of terms, and D is the common difference. And this Sn is the sum of all the terms. Just as we have sum of arithmetic progression, we also have sum of geometric progression. The sum of geometric progression is taken as Sn equal to a into bracket 1 minus r to the power of n over 1 minus r, or a into bracket r is by n minus 1 over r minus 1. We use this first one for the sum of geometric progression if our common ratio is less than 1, and then we use the second one if our common ratio is greater than 1. That is when we use this other one. And lastly, the formula we need to take note of is sum to infinity. We could be asked to sum a particular progression to infinity. Sum to infinity is equal to a over 1 minus r. This is the symbol of infinity. A is the first term over 1 minus the common ratio. Next, so we look at questions on sequence and series. Alright, so here's question 1. Find the sixth term of an AP whose first term is 3 and whose common difference is 5. Now, to solve this question, we have to find the sixth term having a first term of 3 and a common difference of 5. Now, in this case, we'll use the formula for arithmetic progression, which is Tn equal to a plus n minus 1 into bracket d. First term is 3 plus the n, that's the number of term, which is 6 minus 1 into bracket the common difference, which is 5. And so we have 3 plus 6 minus 1, and that's 5, multiplied by 5. And so we have 3 plus 5 times 5, that's 25. Hence, the sixth term equal to 28. Next, we want to solve questions on sequence and series. Question 1 says, what is the common ratio of the GP root 10 plus root 5, all in brackets, plus root 10 plus 2 root 5, all in brackets, plus dash dash dash. In this question, to find the common ratio, we have that in a GP, common ratio as T2 over T1 is also equal to third term over second term, or T4 over T3, or T5 over T4, on and on like that. Now, in this question, we have our second term, T2, to be root 10 plus 2 root 5 over our first term is root 10 plus root 5. When we have a situation as this, what we'll do is that we rationalize. And to rationalize means to multiply both numerator and denominator by the conjugate of this. You will understand this better when you look at our calculation under SOD. So we have root 10 minus root 5 over root 10 minus root 5. Hence, this is the conjugate of root 10 plus root 5. Alright, so we multiply through. We have root 10 times root 10, that gives root 100. Root 10 times minus root 5, that gives minus root 50. And then plus 2 root 5 times root 10, that gives plus 2 root 50. And then 2 root 5 times minus 5, that gives minus 2 root 25 over root 10 times root 10, that is root 100. Then root 10 times minus root 5, that's minus root 50. Root 5 times 10, that's plus root 50. And then root 5 times minus root 5, and that's minus root 25. Root 100 is 10 minus, now we have minus root 50 plus 2 root 50. This is more like saying minus a plus 2a, where root 50 is a, is a over here. And so when you have minus a plus root a, minus a plus 2a, that would give a. And so that's what's going to happen here. Now we have minus root 50 plus 2 root 50, that would give plus root 50. And then minus 2 times root 25 is 5. Alright, divided by root 100 is 10. And here we have minus 50 plus root 50. It's just like having minus a plus a. And and that gives 0. And so this cancels out. And then we have minus root 25, that's 5. We have 10 minus 2 times 5, that is minus 10. And we have plus root 50 is just like saying 2 times 25 inside this root over 10 minus 5, that is 5. And so 10 minus 10, that gives 0. And then this means root 2 times root 25 over 5. That is 2 times root 25 is 5. Alright, over 5. So 5 cancels out. So we are left with root 2. Hence, our answer is root 2. Question. The third term of an AP is minus 9, and the seventh term is minus 29. Find the 10th term of the progression. In this question, we're told that the third term equal to minus 9, and the seventh term equal to minus 29. And here we are dealing with an arithmetic progression which has the formula of Tn equal to a plus n minus 1 into bracket d. Alright, so let's apply this formula into these two information we are given. Tn is minus 9 over here. A is the first term plus n is the third term, that's 3 minus 1 into bracket. D is the common difference which we do not know. And so we have minus 9 equal to a plus 3 minus 1, that's 2d. Next, we'll have T7 as minus 29 equal to first term a plus n, which is 7 minus 1 into bracket the common difference which is unknown. So we have minus 29 equal to a plus 6d. Here is equation 2. Next, we have two equations over here, and we can solve them using simultaneous equation. And we could solve them either by using elimination or substitution method. And so let's use elimination method. Let's place this minus 9 over here. Alright, now we can say that equation 2 minus equation 1. So if you say equation 2 minus equation 1, we'll add with that minus 29 minus 9 equal to a minus a plus 6d minus 2d. Here we have minus 29 plus 9 equal to a minus a, that's 0, and then 6d minus 2d, that gives us 4d. And so minus 29 plus 9, that gives us minus 20 equal to 4d. Hence, d equal to minus 5. So that's the value of our common difference. Next, we can get the value of a by substituting minus 5 for d in any of the equation. So we could use equation 1. So if we have it as minus 9 equal to a plus 2 into brackets minus 5. So we have minus 9 equal to a plus minus 10. We have a will be equal to minus 9 plus 10. So a equal to 1. So in the question, we are asked to find the 10th term of the progression. And so we have that T10 equal to a plus n minus 1 into bracket d, where the first term is 1, n is the 10th term which we are to find, and then d is the common difference which is minus 5. So we have 1 plus 10 minus 9, 1, that's 9 times minus 5. And so we have 1 plus 9 multiplied by minus 5, that is minus 45. So we have 1 minus 45, the answer is minus 44. Hence, the 10th term is minus 44. Next question. The nth term of a sequence is n squared minus 6n minus 4. Find the sum of the third and the fourth term. Over here, we have a general equation or a general sequence which is n squared minus 6n minus 4. And we are asked to find the third term, T3. And so we'll place 3, we'll substitute 3 into the values of all of the n. So we have 3 squared minus 6 into bracket 3 minus 4. Alright, so we have 3 squared, which is 9, minus 3 times 6 is 18, minus 4. Now we have 9 minus 18 minus 4, that leaves us with minus 22. So 9 minus 22, we have minus 13. That's the third term. And then the fourth term, we have to replace n with 4. So we have 4 squared minus 6 into bracket 4 minus 4. 4 squared is 16 minus 6 times 4 leaves us with minus 24 minus 4. Minus 16 minus 4, we have minus 28. And so 16 minus 28, we have minus 12. So we have to find the sum of the third and the fourth term. So the sum equal to the third term, which is minus 13, plus minus 12. That's minus 13 minus 12, and that is minus 25. Next question says, find the sum of the first 18 terms of the series 3, 6, 9, ellipses, and then 36. Alright, so we have this sequence 3, 6, 9, ellipses, and then 12. Here we have an AP, and this AP, the first term is 3. That is a common difference of, like, this is the second term, that's T2 minus T1, or T3 minus T2. That's how I can get the common difference, or T4 minus T3, and so on and so forth. So the common difference is that the T2, which is 6, minus T1, which is 3, and that gives us 3 as a common difference. We have to find the sum of the first 18 terms, so meaning that our n equal to 18. Now the formula which we use is sum of the n terms of an AP equal to n over 2 into bracket 2a plus n minus 1 into bracket d. Now this is the formula we use, or we could use n over 2 into bracket a plus l, where l is the last term. And so in this question, we could use the two formulas. But let's make use of the first. Our nth term is 18. That's 18 over 2 into bracket 2 multiplied by a. The first term is 3 plus n, which is 18 minus 1, and then the common difference is 3. So we have 18 divided by 2, that's 9, into brackets 2 times 3 is 6, plus 8 minus 1, that's 17. 17 times 3, 17 times 3, that gives us 51. So we have 9 into bracket 6 plus 51, that's 57. 9 times 57, that gives 513. Hence, the sum of the 18 terms of this AP is 513. Alright, so next question. Find to infinity the sum of the sequence 1, 9 over 10, 9 over 10 squared, 9 over 10 cubed, and so on. We have that sum to infinity equal to a over 1 minus r, where a is the first term and r is the common ratio. Here, the first term, a, equal to 1. And to get the common ratio, we'll have that the second term divided by the first term. Here, the second term is 9 over 10 divided by 1. That is 9 over 10 times 1, and so that's 9 over 10. So next, we'll substitute this into the equation. So sum to infinity equal to a, which is 1 over 1 minus 9 over 10. Alright, so we'll deal with this denominator first. We have 10 over here, so 1 into 10, that gives 10. 10 times 1 is 10. 10 into 10, 1. 1 times 9 is 9. So we have 1 over 10 here. And so we have sum to infinity equal to 1 over 1 over 10, which is same as saying 1 divided by 1 over 10. So sum to infinity equal to 1 times 10. Hence, the sum to infinity is 10. Here, next question says the sum to infinity of a GP is minus 1 over 10, and the first term is minus 1 over 8. Find the common ratio of the progression. We have that the sum to infinity equal to minus 1 over 10, and it has a first term of minus 1 over 8. We have to determine the common ratio. Alright, so in this question, we have that sum to infinity equal to a over 1 minus r. Here, our sum to infinity is minus 1 over 10, and our first term is minus 1 over 8 divided by 1 minus r. So we'll solve it like this. I have minus 1 over 8 multiplied by 1 over 1 minus r. The changing of this division to multiplication causes the 1 over r to move down, and then 1 comes up. Then we have that 1 times 1 is 1, and then we have minus 1 over 8 multiplies this, that's 1 minus r, equal to minus 1 over 10. First, we have that minus 1 over 10 equal to minus 1 over 8 multiplies 1, that's 8 minus 8r. At this junction, we will cross multiply. So we have minus 1 into bracket 8 minus 8r equal to minus 1 times 10. Minus 1 times 8, we have minus 8. Minus times minus gives us plus 8r equal to minus 10. We collect like them, so we have 8r equal to minus 10 plus 8, and that is minus 2. And so r equal to minus 2 over 8. So r equal to minus 1 over 4. Hence, that is the common ratio. Here's the next question, and it says, find the sum to infinity of the series 2 plus 3 over 2 plus 9 over 8 plus 27 over 32, and so on. Now, to find the sum to infinity, first, we have that the first term equal to 2. And then to get the common ratio is T2, we can make it as T2 over T1. Here, our T2 is 3 over 2 divided by T1, which is 2. Now, this is equal to 3 over 2 multiplied by 1 over 2. And so 3 over 4 is the common ratio. We have that sum to infinity equal to a over 1 minus r. A is 2 divided by 1 minus r, that is 3 over 4. So first, let's tackle this. We have 4 here. 1 into 4, 4. 4 times 1 is 4. 4 into 4, 1. 1 times 3. So we have 1 over 4. So we have that sum to infinity equal to 2 divided by 1 over 4, which is 2 multiplied by 4. So sum to infinity equal to 8. Here is the next question, which says that if the ninth term of an AP is 5 times the fifth term, find the relationship between A and D. Alright, so for us to solve this question, it's quite simple. We're told that if the ninth term of an AP, so that's T9, is 5 times the fifth term, we have to find the relationship. So Tn equal to A plus n minus 1 into bracket D. That is the formula for AP, arithmetic sequence. Now we have that if we have T9 equal to A plus n, which is 9 minus 1, let's have this in the proper form. That will be T9 equal to A plus 9 minus 1, that leaves us with 8D. We can call this one equation 1. We will parallel it with the other, or with the fifth term. So we have T5 equal to A plus 5 minus 1 into bracket D. So we have T5 equal to A, 5 minus 1, that gives us 4D. This is our equation 2. At this junction, we have that T9 equal to 5 times T5. And if that is the case, we could have it that this is T9. Right? So we have T9 equal to 5 times T5. Our T9 is A plus 8D. Then 5 multiplied by T5 is A plus 4D. Let's open this bracket and we'll have A plus 8D equal to 5A plus 20D. Let's collect like terms. Let's bring this 20D over here. That will be 8D minus 20D equal to 5A minus A. Here we have minus 12D equal to 4A. We divide both sides by 4. Hence, we have minus 3D equal to A. So we could say that this is the relationship between A and D. Or we could move this over here and we'll say that 0 equal to A plus 3D. So any of this could serve as the relationship between A and D. Next question says, 3 consecutive terms of a geometric progression are given as n minus 2, n, and n plus 3. Find the common ratio. Here we have that the first term is n minus 2. We have a second term, that's t2, which is n. And we have a third term, which is n plus 3. And we are asked to find the common ratio. We know that the common ratio equal to t2 over t1. Alright, so we have t3 over t2. Now, in order to get the common ratio, we need to put in all the values that we are given here, and with that we'll get the value of n, and with the n we can get the common ratio. And so our t2 is n and t1 is n minus 2 equal to t3, which is n plus 3, and t2, which is n. We'll cross multiply this, that is n multiplies n equal to n plus 3 multiplies n minus 2. N times n is n squared. N times n here is n squared minus 2n plus 3n minus 6. Next is we collect like terms. We could have here as n squared minus n squared equal to minus 2n plus 3n. Here we have n minus 6. And so this cancels out. And we are left with 0 equal to n minus 6. So n equal to 6. That's the nth term. But then we have to find the common ratio. So the common ratio is, just as I said, 2t second term over first term, or third term over second term. But let's use this. Now the second term is n, and the first term is n minus 2. So with this information, n is 6. So we have 6 over 6 minus 2, which is 4. And so our common ratio equal to 3 over 2. Here's the next question, which says that the sum of the first n terms of an arithmetic progression is 252. If the first term is minus 16 and the last term is 72, find the number of terms in the series. So in this question, we have to find n. We're told that the sum of n equal to 252. And we're told that the first term is minus 16, and then the last term, L, equal to 72. We have to find the value of n. We have a formula that says that sum of nth terms in an AP equal to n over 2 into brackets 2a plus n minus 1 into bracket d, right? And we have a second one which is similar, which is n over 2 to bracket a plus l. They are both derivatives of each other. Now we are going to use this. We are going to use this because we are giving our L as 72. We are not giving the value of D in the question, and we won't be working with two unknowns. Now, so we have our sum of n10, which is 252 equal to n over 2 into bracket A, that is minus 16, plus L, that is 72. 252 equal to n over 2 into brackets 16 minus 16 plus 72. We have 56. So this is n over 2 times 56. Here we have 28. So 252 equal to 28n. Hence n equal to 252 over 28. The value of n equal to 9. So we have 9 terms. Here's the next question, which says the third term of a GP is 4, while the sixth term is 32. Find its common ratio. Over here, we have the third term of a GP to be 4 and the sixth term equal to 32. We have to find its common ratio. First, our formula for nth term of a GP equal to ARn minus 1, where A is the first term, R is the common ratio, N is the number of terms. Alright, so what we'll do is this. For T3, the value of T3 is 4, so 4 equal to AR, and our N is 3, so we have 3 minus 1, giving us 4 equal to AR squared. Here we'll use this as our equation 1. And next, our T6 is 32, equal to AR N, which is 6 minus 1. So we have 32 equal to AR raised to power 5. We'll call this equation 2. We have two unknowns here and we have two unknowns here. And so this can be solved simultaneously. It can be solved by having 32 equal to AR raised to power 5 and then 4 equal to AR squared. This equation 2 and this equation 1. We want to eliminate this A by saying equation 2 divided by equation 1. And so we'll have 32 over 4 equal to A over A, and then R raised to power 5, R raised to power 2. 4 here, 4 gives us 8. Then A cancels A. We have 8 equal to R raised to power 5. When this R and R are the same, except that the powers are different. And so you move these 2 over here, become 5 minus 2. So 8 equal to R raised to power 3. We have R equal to 3 comes over here and becomes cube root of 8. So R equal to 2. Next question. The sixth term of an AP is half of its 12th term. The first term is equal to what? Here, in an AP we have that the sixth term equal to half of its 12th term, which is T12 over 2. We have to look for a solution around this. Now, making use of all what we are given, we have that Tn equal to A plus n minus 1 bracket D. That is the formula for an AP. Next, T6 equal to A plus n, which is 6 minus 1 into bracket D. And so we have T6 equal to A plus 5D. And for the other one, that is 12th term equal to A plus 12 minus 1 into bracket D. So we have T12 equal to A plus 11D. Since we have that T6 equal to T12 over 2, we could substitute this into this fraction, and that gives us A plus 5D equal to A plus 11D over 2. With this, we'll cross multiply, and so 2 comes here. We have 2 into bracket A plus 5D equal to A plus 11D. 2A plus 10D equal to A plus 11D. Let's bring like terms together. We have 2A minus A equal to 11D minus 10D. And so we have 2A minus A leaves us with an A equal to 11D minus 10D, that is D. So we have that the first term is equal to the common difference. Next question. The fourth term of a geometric sequence is 24 and the seventh term is 192. Find the sum of the first 8 terms. Here we have a geometric progression in which the fourth term equal to 24 and its seventh term equal to 192. Here is the formula for nth term of a GP, that is Tn equal to ARn minus 1. With this information we are given, we could find R and A. Now, we have that the fourth term is 24. So we have 24 equal to A R. N is 4, so 4 minus 1. So we have 24 equal to A R raised by 3. And then the seventh term we're given as 192 equal to A R 7 minus 1. So we have 192 equal to A R raised by 6. We will have this as the first equation and here as the second equation. So we could say equation 2 divided by equation 1, and that will give 192 over 24 equal to A R raised by 6 over A R raised by 3. 192 divided by 24 gives 8. A cancels A, and then over here we have R raised by 6 minus 3. So we have 8 equal to R raised by 3. So we bring this 3 over here and we have it as cube root of 8 equal to R. Hence R equal to 2. Next, we need to find our first term after we have known our common ratio. So we have it that if R equal to 2, let's substitute 2 into R in equation 1. So we have 24 equal to A into bracket 2 to the power of 3 here. Since our R is 2, so we have 2 there. So we have 24 equal to A, 2 raised by 3, that's 8. So A equal to 24 over 8, and that is 3. So the value of A is 3. Next, we were told to find the sum of the first 8 terms. In GP, we have two formulas for sum of n terms, which is A into bracket R raised by n minus 1 over R minus 1, or A into bracket 1 minus R raised by n over 1 minus R. We will use 1, and the one we use depends on the value of our R. If our R is greater than 1, we will use this. But if R is less than 1, we will use this. And in this case, our R is 2, and so we'll make use of this. So next, we have that our first term is 3 into bracket R, which is 2 raised by n, which is 8 term, minus 1 over R, which is 2 minus 1. With this, we have 3 into brackets 2 raised by 8 gives 256 minus 1 over 2 minus 1 is 1. And so we have 3 into brackets 256 minus 1, that's 255. 3 multiplied by 255, that gives us 765. Hence, the sum of the first 8 terms of this geometric progression is 765. Next question says, the sum of the first n terms of the AP 5, 11, 17, 23, 29, 35 ellipses is what? Now in this question, we have an AP which has a first term of 5. It has a common difference, which is the second term, 11, minus the first term, and that is 6, right? So that's the common ratio, and that's the first term. Next, we have to find the sum of the first n terms. And we have that sum of the n terms in an AP equal to n over 2 into bracket 2a plus n minus 1 into bracket d. In this question, we do not have the value of n, but we have the value of a and d. And so we'll use that and substitute into this equation. Now we have n over 2 to bracket 2 multiplied by a, that is 5. Alright? Plus n minus 1 into brackets d, which is 6. Next we have n over 2 into brackets 2 times 5 is 10, plus 6 will multiply each of the value or letter inside this bracket. So we have 6n minus 6. We could collect the like terms here. So we'll have that n over 2 into brackets 10 minus 6, that's 4, plus 6n. Next, we'll open these brackets Okay, we could use this to multiply each of the numbers inside this bracket, or let's take it like this: n over 2 multiplied by 4 plus n over 2 multiplied by 6n. Since this n over 2 is meant to multiply each of the numbers inside this bracket, so 2 cancels 2, for we have 2 here, and then we have 3n. So we are left with 2n plus 3n squared. So we have that the sum of the first n terms of this AP is 2n plus 3n squared.